be a summer, and here this section is added with this. Suppose here multiplier is there, and this multiplier here, the constant a is multiplied with this, and here actually yn minus 1, this will be added with xn. So here at the output of the adder you will get xn. Okay, I am writing the first ayn, then ayn minus 1 plus xn. So two inputs are there. One input is xn, another input is ayn minus 1, and these two things are added. Okay, and here this a is multiplied with yn minus 1, so here it will be yn minus 1, and this is your yn actually, because yn is equal to this, so this is your yn, and here you have to use one delay unit. Here actually you see yn is coming at the input of the delay unit, and if it is your z to the power minus 1, then output of this block will be yn minus 1. So yn minus 1. So this is the delay unit. Input is yn and output is yn minus 1, one sample delay, and this is actually coming here, and this is multiplied with an, and it is added with xn, and it is the block diagram of this particular linear system. Now you see I have used one adder, one multiplier, one delay unit to design this system, discrete time system. Okay, this is pictorial representation. Now everything can be, it is possible to write a program to realize this particular system. And what we should know the initial condition of the system. That is, initial condition means if you start n from 0, then y of minus 1, that is the initial condition. This, whether the system is initially relaxed or not, this should be known to you. If you know that initial condition, then you can find out the output yn for a given input xn. Okay, so this is the implementation of discrete time system. If the discrete time system is described with the help of input-output equation, difference equation, okay, then that can be realized with the help of different blocks, that is adder, subtractor, multiplier, delay unit, etc. Okay, and one of the most important realization is this. This is one system, discrete time system, and its realization with the help of the blocks is this. Okay, now today along with this I want to discuss about the classification of discrete time system. Classification of discrete time systems. Okay, now here, based on the type of operation and the nature of the system, we can classify the discrete time systems into several categories. The first one I want to discuss, which I want to discuss here, that is static system and dynamic system. Static system and dynamic system. Okay. And what is static system? A discrete time system is called static. This static system is sometimes called memoryless system. Okay. So this static system is also called memoryless system. Memoryless system. And the definition of this static system, I want to say. Okay. Now the definition of static system is this: a discrete time system, is called a static or memoryless system. If its output at any instant n depends on if its output at any instant n depends at most on the input sample at that same time. Input sample at that same time instant. Okay. So in case of static system, the output at a particular time instant n depends on the input at that particular time instant, applied at that particular time instant. Okay, that means if you want to give one example of input output system for a static system, what I can write, suppose yn is equal to axn. If you take this system, this is the input output relationship. Output at a particular system n is dependent on the input at that particular instant n. Okay, so this is your static system. Similarly, yn is equal to, for example, nxn. I am writing here, suppose nxn plus a x square n. This is a second order system, means quadratic system. But here again we see that output at a particular instant n depends on the values of the input at that particular instant n. Okay, so this is static system or memoryless system. For this system there is no memory. I am not doing like this, that I am not storing some data on the memory location of the system and I am not recalling that data for future operation. Okay, so therefore this is called static system, and at the same time it is also called memoryless system. Okay, and the dynamic system is the system with memory.
Was the second example also a static system?
Yeah, that is also static system, but that is a quadratic system, because we are taking the square of the input. The second term of the right hand side, you are taking some a x square n. This second term is actually the nonlinear term. So the system is nonlinear type of system, or square, that is a quadratic system. Okay, which is taking the square of the input signal, but the sample value or the signal is taken for that particular time system. What input you are taking? You are taking the input at nth time instant. It is not that you are taking some input at n minus 1 time instant. Just 1 minute. Hare Krishna Prabhu. আচ্ছা, আপনি ইয়ের ফোন নাম্বারটা আছে? আমি তো আমি এখন ক্লাস নিচ্ছি, হ্যাঁ, তো আমি একটুখানি ইয়েকে বলে দিচ্ছি, আপনি একটু ওর সঙ্গে কমিউনিকেট করে নেবেন। হ্যাঁ, আমি ইয়েকে, হ্যাঁ, 1 মিনিট আমি বলে দিচ্ছি, 1 মিনিট। Okay. So what I am discussing here, that in case of dynamic system are also called systems with memory. Systems with memory. Dynamic systems are also called systems with memory. Okay. Now, what do we mean by dynamic system? So, if we see that the input, the output of that system, the output of that system yn, depends not only on the present input at that instant, but also the previous inputs and previous outputs. Okay. That means if you see that yn is equal to some xn plus a xn minus 1 like this. Here you see the output at any time instant n depends on the input at that time instant n and also the input, the previous input. This is the previous input. It is the input at n minus 1 at time instant. So this input, this previous input is stored in the memory location and it is used for computation of the output in the next step, next time instant n. Okay. Therefore, this is called actually dynamic systems. And memory, it is a system with memory. So this is one dynamic system. Then another system you can think that it is dynamic system, that is yn is equal to, for example, k is equal to 0 to n x n minus k. This is also another system which is called dynamic system. Okay. It is also dynamic system. Now next, what I want to say, based on the time variancy, the system can be categorized into two systems: time invariant system and time variant system. Okay.
Sir, sir, you're muted, sir.
Just 1 minute. Okay.
Oh,
Just 1 minute. It is sorry. Now, am I audible?
yes, sir.
Okay. So next I want to discuss about, so this is actually this classification, time invariant and time variant. This classification is done based on time invariancy property. So let us try to understand what is time invariant and what is time variant system. Okay, so number 2, time invariant and time variant system. Time invariant and time variant systems. Okay. Now, in case, what do you mean by time invariant system? This is most important thing. Just let us try to understand this time invariancy with the help of a graph. Okay, suppose you have an input signal xn, and this input signal is like this. It has 3 sample values. This is input signal. Okay, and suppose the system is such that yn for this system is like this. It is like this. I am giving arbitrary output just. Suppose the system is such that at the output it is giving like this. This is n. Okay. Now this is input and this is output. The input sample starts from 0, 0 for 0, 1 and 2. We are getting these 3 samples. And output also, I am getting the output for n is equal to 0, 1 and 2. Now, it may be that you can shift the input signal. Suppose you are just creating one sample delay of this input signal. For example, one sample delay will give you this kind of signal structure. This has been shifted. Here 1, it is 2, it is 3, and this is 0 now. Okay. So the signal xn has been shifted, and this is your xn minus 1. Okay. Now, if you apply this signal to the same system, which is producing this output from this input, this xn output you are giving to the system, and you are getting yn, this yn. Now, you are shifting the input signal from here to here, and you are giving this to the input of the same system. And if you see that the system, is producing the same shape of the output like this, but the output is also delay. That means actually you are getting yn minus 1 at the output. Then we will say that the system is called time invariant system. So whenever you are shifting the input signal xn, and you are applying that shifted signal to the input of the same system, and the system which was producing this output yn, it is now producing the shifted version, and amount of shifting will be same. The shifted version of the previous yn, then the system will be is called the time invariant system. So mathematically, we can write in this way that suppose a signal xn is applied to the input of the suppose this system you are applying in at the input xn, and at the output you are getting yn. Suppose this is the DTS, and then suppose you are shifting the signal xn, and you are applying xn minus 1 at the input, and if you see that output is produced here, which is in the form of yn minus 1, that is output is also shifted, and the amount of shifting is same amount, then this DTS is called time invariant time invariant system. Okay, that means if yn is equal to response to or transformation to, you can write t also here. This is the response I am writing, okay, xn, and suppose if you see that for the same system is giving like this, yn minus 1 for the shifted version of the input, same input xn, okay, then the system is called time invariant for a time invariant system. In general, you can write k. If you take k samples delay, then output will be also k samples in general. Okay. So if yn is the response to this xn, and if you apply xn minus k to the input of the same system, and if you get yn minus k at the output of that system, then the system will be called the time invariant system. If it is not that yn is the response to xn, but you are giving the delayed version or shifted version of xn to the input, and you are not getting the output which is the shifted version of the previous output, you are not getting that, that is not equal to, then the system will be called time variant system. So it is not time variant system. Okay, this is the difference between time invariance and time variant system. Now this is based on time variance. And then number 3, linear system and non-linear system. Linear and non-linear systems. Linear and non-linear systems. So what is linear system and what is non-linear system? Linear system, actually it should follow the principle of linearity and superposition. It is like this. Suppose I have a system, okay, this is our discrete time system, and at the input you are giving some input signal x1n, and for that you are getting the output y1. Then what you can write, y1n is equal to response to x1 or transformation to x1. Similarly, if you apply x2n to the input, so in place of x1n, suppose you are applying x2n, and you can get corresponding output, for example, y2n is the output. Then what you can write, y2n is equal to response to x2n. Now let us, you apply the linear combination of the inputs of the input signals x1n and x2n to the same system. That means to the same system you apply ax1n plus bx2n. ax1n, a is constant, so you are taking, and b is constant. So what you are doing, you are taking the linear combinations of two input signals x1n and x2n. And if you see that at the output you are getting this yn is equal to ayn y1n plus by2n. That means at the output also you are getting the linear combination of the previous outputs, these outputs, with the same constants a and b. Then the system is following the linear and superposition theorem, and you will say that the system is a linear system. So this is the linear system. Okay. So for linear system,
sir, could you repeat the definition, sir, of linear system once more, sir? Sir, could you
system
repeat
which follows, the definition is simple. The system which follows the linear and superposition principle, that is called linear system. Okay, that is the definition. And what is the meaning of that? That linear superposition. Linear meaning is this. Suppose I have input signal x1n, and for this x1n you are getting some output y1n. If you change this input signal to x2n, then you are getting the different output y2n. Then you are taking the linear combination of the previous two inputs ax1n and bx2n. You are giving that linear combination to the input of the same system. And if you see that the output is also the linear combination of the previous two outputs with the same constants a and b, then the system is called linear system. This is the mathematical interpretation of the linear system. And the definition is this: as a system which follows the linear superposition principle, that is called linear system. Okay. And if you follow, suppose, a system input output relationship is given like this. Suppose yn is equal to, for example, ax square n. Can you say what is this? Whether it is linear system or non-linear system? You have to check it. The question may come like this. Suppose the input-output relationship of a system is given by this relationship, this equation. Then you try, you check whether the system is linear or non-linear. Okay, this will be a non-linear system. You have to check it. Okay. And if linear superposition theorem is not valid for a system is not obeying the linear superposition principle, then the system is called non-linear system. Okay, so this is non-linear system, and yn is equal to, suppose, axn. This is a linear system. Similarly, yn is equal to axn plus some constant b axn minus 1. This is also linear system. Okay, but this is non-linear. This is linear. Like how can you prove? You have to check whether the system is following the linear superposition principle or not. Okay. For every case, for every case. Okay. Similarly, if you take a system like this, yn is equal to axn plus bx square n. This is also non-linear system. You can prove it by checking the linear by checking whether the system is obeying the linear superposition principle. Okay. Okay. আমি একটু ক্লাস নিচ্ছি, ক্লাস নিয়ে ফোন করছি, হ্যাঁ। So this is the case. Now fourth one is causal and non-causal system. Causal and non-causal system. Okay, causal and non-causal system. If a system output depends on the present input and the past outputs or past inputs, then the system is called causal system. Okay. That means a system at a particular instant is depend on the input signal applied at that particular instant and the previous inputs or previous outputs. That is called causal system. But if you see that the system output at a particular instant depends on the future input, then this is called non-causal system. Non-causal means the output at a particular instant depends on the future inputs. So physically, generally we do not see this kind of system where the output at a particular instant depends on the future input. It is not getting the input at this moment, but the output at this moment is dependent on the future input. So this is, in reality, we do not see this kind of causal system. But in case of this is non-causal system. But in case of causal system, the output at a particular instant depends on the input applied at that particular instant and the past inputs or past outputs. If some past inputs are applied, the future output, the output at this moment is dependent on the past inputs also. Or some past outputs can depend because the past output can be stored in the memory location and it can be used. Okay, so that is called causal system. And non-causal system, thus output of the system at a particular instant depends on the future input. Okay. So for causal system, output yn can be written as a function of xn, xn minus 1, xn minus 2, xn minus 2 dot x n minus, suppose capital M, n number of n plus 1 numbers of sample zero taken, suppose. Okay. Similarly, this is for causal system. But for non-causal system, yn is equal to function, present, past also. It can depend past input also. And at the same time, xn plus 1, comma, xn plus 2, comma, dot x n plus capital N. So you see the output at a particular instant, nth instant, is dependent on the input at that instant, the previous inputs. These are the previous inputs and these are the future inputs. This is your non-causal system. Okay. And so today, 4:25. So again, tomorrow I will discuss about the stable system and unstable system. After define these systems, I will try to characterize the linear time invariant system in details. And I will try to show how we can determine the system response if a given input sequence is applied to a linear time invariant system. Okay, today after this.